Hello, everyone. Welcome to Soil Mechanics. My name is Evan Carter, and I'm going to talk about the USDA soil system. Let's begin. Before we get started, I want to say that this is probably one of my favorite systems, just because of my background a little bit. I like to be outdoors and stuff, and I actually have a friend that works with farmers and people around the country to help produce better crops and everything for them. So he deals with some of this stuff too. So knowing a little bit of that plus what we learn in school here definitely makes me more interested in this. So, okay, let's begin. Okay, so the introduction of USDA. So the full name of USDA is the United States Department of Agriculture. I like this definition here that I got from a video. It says mission. The USDA's mission is to provide leadership on food, agriculture, natural resources, and related issues based on sound public policy and the best available science and effective management. So USDA is definitely, I would say, one of the important aspects when it comes to the United States. Just because we're all humans and we all need to eat, and we all want to eat good, healthy food. And the people's jobs at the USDA and farmers and people that do agriculture is to produce the best food and natural resources to us. And more for the outcome, the better the product, the more money you make or more customers you might get, etc. The USDA stands for United States of Agriculture, like I said, and it's a federal agency that Abraham Lincoln found in 1862. I actually found that pretty interesting. I'm going to underline that here. Abraham found in 1862. So before this, I actually did not know that. So that's a cool fact. But so yes, it is a federal agency that Abraham Lincoln found in 1862. The USDA is responsible for overseeing farmers, ranching, and forestry industries, as well as regarding aspects of food quality and safety and natural labeling. So, like I said a little bit before, when I talked about farming and ranching, so that's cattle, that's pigs, that's all how we get our meats. That's how we get our vegetables. That's how we get a lot of the food that we buy in stores, the local stores, local convenience stores. Most of that stuff comes from farmers and ranching and forestry industries. So that's definitely a big one right there. The last bullet point I have here is the purpose of this test is to provide a standard produce to estimating soil texture in the field. So I actually have a little bit of experience with this. I actually have a relative that is a farmer on the side. He does a little bit of farming on the side. And actually, during the summer, got to help him, and he taught me a lot about the testing of the soil. So every couple years, or every year, whatever that farmer wants to do, or rancher, or whoever might be wanting to do this test, they basically go and get a couple samples of soil in their fields, and then they would send it off to labs and get it tested for them, and then they would get a bunch of results back on their soil that they have in their fields. So so it says here the texture is estimated by the feel of the moist soil. So basically that's saying that when you get the soil, you can basically feel the moist soil. So is it dry soil? Is it wet soil? You can kind of feel that moisture in that soil. The texture of the soil cannot be estimated by feel if it is either dry or wet. So again, going back to what I just said, this says the texture is estimated by the feel of the moist soil, but then it says here the texture of the soil cannot be estimated by the feel if it is either dry or wet. So a lot of things go into this. We'll dig deeper into some of this into the video here, but so yeah, that's kind of an introduction of the USDA. Again, the title of it is the United States Department of Agriculture, and its mission again is to provide leadership on food, agriculture, and natural resources. So that's probably the top three: food, agriculture, and natural resources is probably the top three things that is definitely important in the USDA. So let's dig deep into a little bit more here on the next slide here. Okay, so here is the grain size. Okay, so we're going to talk about grain size right here. So it says here, in the United States, 12 major soil texture classifications are defined by the United States Department of Agriculture. So within the United States, the USDA department, there are 12 major soil texture classifications. That's very important, just for the simple fact is I'm actually gonna erase that. Wait, can I? Yeah. And I'm gonna highlight that because that's gonna be a big one right there. 12 major classifications in the USDA. So going on here, and it's going to explain the 12 classifications. So the 12 classifications are sand, soily sand, sandy loam, silt loam, sandy clay loam, silty clay loam, sandy clay, silty clay, and clay. So I know that was a lot. No, there are 12 of them, and it sounds like I'm saying the same thing over and over, but actually I'm not. They're all different. They're all different soil texture classifications. They're all different soils. So down below here I have gravel here. Here's the gravel. So gravel, it says particle sizes from 4.75 to 75 mm. So that's for gravel. Sand is right here, and it says particle sizes from 0.075 to 4.75 millimeters. And then down below here we have fines. Fines is going to be what it says right here are going to be our silt and our clay. And this says particles smaller than 0.075 millimeters. So that's pretty small. Definitely smaller than the sand, obviously, and definitely a lot smaller than the gravel. So when we get talking into some of these textures and soil textures here, I want to let you guys keep in mind that all 12 of these classifications are all different. Every single soil is all different, but they all undergo either gravel, sand, and fines. So let's, I would definitely, if you guys are taking notes here, I would say definitely write down all those 12 majors, because those are definitely going to be coming into play a little bit later. Let's go forward. Okay. So, now getting into the sieves used for the grain size. So, doing a little bit of research and a little bit of knowledge of what I experienced with my friend already and my family members and what I've learned in school. The USDA recommends different sieves for different grains. So, obviously, there are different grains, different soils, different all that. So, here it says that barley is a 5/64 in a triangular hole sieve. So that is, so for barley, grains, soil, etc., you would use 5/64 in a triangular hole sieve. So basically, if you guys aren't familiar what a sieve is or sieves, basically, it's basically, if you imagine like a 5-gallon bucket or a little bit smaller than that, like just a little bit smaller than a 5-gallon bucket, and just imagine every inch of that bucket, there's a let me explain. I'm trying to think here. There's a piece of fabric that goes across with a different number of holes in them, if that makes sense. So the top part of that bucket with that fabric going over top will have a lot bigger holes, and then from the top of that, for example, the bucket, you would, every inch that you go down, or every sieve you would go down, would get smaller in holes, and it would gain holes. So you go from the top of what you're starting to the bottom, which would be, it would go from big holes to very, 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 very small holes. So just a little thing on what sieve is here. A little bit of more information here. These are a different amount of seeds that you can use for sieves. Like I said, for using it USDA, and it's all agriculture, all grain sizes and stuff. So there's all different types of grains. So they have to use different types of sieves. So here, you got like your rape seed right here. You got different kinds of little seeds, mustard seed. Okay, so you're going to be using any of these numbers right here, 3/64 in a 3/8 inch hole sieve. Here for this seed right here, you're going to use a 0.089 in a circular triangular hole sieve on the top of 4.5/64 in a round sieve hole. So just a little information here about what the different number of sieves are. Here's a big one right here, wheat and rye. There's a lot of wheat, and we use a lot of wheat and a lot of rye in the United States. So if you want to know how they sieve all that out from big grain to small grain, stuff like that, this is how they do it right there. I got a little summary of all of the sieve analysis down below. So sieve analysis is a common method of measuring grain size. In this method, all soil passes through sieves of a different size to capture different size ranges. So like I said a little bit before, I know that probably explains it a little bit better, but just try to imagine a 5-gallon bucket, and then you just have different layers of fabric going across with different size holes. That's basically what it's saying. So you dump whatever soil you're trying to find the range of, and you're just going to dump it at the top, and then you would put the lid on, you would shake it around a little bit, and then you would open it up, and then you would have different soils at different levels of that bucket. So that's how you test that. But it says, however, Other methods are more effective for characterizing materials below 2,000 micros to 2 millimeters or 2 millimeters. These include semi-mentioned methods such as the hydrometer and pipette meter methods, or optoidal methods such as a X-ray, laser diffusion, and IRN scaloscopy right there. So a little bit into that. That's a little bit more higher up if you really want to dig into some of that stuff. With this being a grain size in the U.S. for agriculture, you would use that more for agriculture, stuff like that. For this, say, let's just say you were talking about USCS, that's more soil here. So you probably wouldn't be using this stuff in, let's say, USCS. So here in USDA, with it being grains and different size grains, different size seeds, different size this and that, you might not be able to do the sieve analysis depending on this, the seed. And if you want to be more productive and have a better effect for the different size captured, then yeah, you would maybe have to use these different options right there. So let's move on to the next slide here. Here I have a little chart for you guys of what the USDA uses. This is their chart. Okay, so here you can see they have clay over here, they have silt over here, and down below here they have sand. Okay, so this is, like I said, this is the USDA textural classification chart. Okay, and here I have a little of information of like silt, clay, sand. Okay, so like silt, clay, sand, and how they determine what all that's about. So you can read through that, and that'll give you a little bit more information on what I talked about before about the grain sizes and stuff like that. What I want to talk about is this big paragraph down here. So this paragraph right here talks about the soil texture, refers to the relative preponderance of sand, silt, and clay particles in a soil material that has a particle size less than 2 millimeters in a diameter. So like with the slide previous to this, that's what that just said. Soil texture is an indicator of infiltration, capitalization, degree of drainage, as well as other physical characteristics of a soil material. So a little information here, but definitely this chart is a big one, because this is what a lot of people use in the USDA industry, and how they figure out the different types of silt, clay, and sand. Okay, additional information to define soil types in the USDA. Remember, United States Department of Agriculture. Okay, so what I have here is soil properties that can be measured. Quantity are usually in this classification system. They include the depth, the moisture, temperature, structure, texture, capitalization, exchange, capacity, base, saturation, clay, mineral, organic matter content, and salt content. So a little information about that. So with this being agriculture, sand, this and that, when planting some crops and different types of grains, some of the seed needs to go a certain depth into the ground. I don't know if any of you guys know how to, like, for example, like grass seed. I don't know if anybody is out there is a hunter, but some people put out food plots. Some people plant just regular gardens. Your tomatoes, your cucumbers, all that stuff. Each seed, when you buy the bag or anything at a store, it usually gives you instructions on how to plant that seed. And usually it gives you a depth because some seeds do better when they're a 1/4 inch into the ground or a 1/2 inch into the ground, etc., etc. A lot of it of the moisture, the temperature, the time of the year would be moisture. Are you getting not enough rain, or are you getting too much rain? Same thing with the temperature. Are you planting it too early, where it's just going to be too hot? Things like that. That all goes into what the USDA does and how they do their things here. So what this says, the USDA's soil taxidermy system extincts of 6 levels. So there's 6 levels in the USDA taxidermy system. And here are the levels. These levels, in order from most general to most specific, sorry, I can't say that word, are order, suborder, great group, subgroup, family, and series. So a little information on that. So when you do these tests and do some of this stuff, there's different levels that you would have to proceed and do, and here they are. These are the order. This is the order, like it said right here, from most general to most specific. Okay, so the USDA compared to other classification systems. So, the USDA of Agriculture soil system, classification system, is related simply to apply, while the United Soil Classification System, USCS, is more complex. As a result, the USDA system, or a simpler method, is more commonly used. So, regarding the comparison, and like I said a little bit before, the USDA to the USCS right here, like it says right here, it is related simple to apply. So, regarding what you're trying to test, different types of testing, what you're trying to do, is depending on what soil system you want to use. So down below here it says the USDA soil classification system is related simple to apply, while the USCA and the AASHTO classification system are more complex. There is more direct relationship between these soil systems, and moving from one system to another can be tenuous and inaccurate. So, again, talking about these two systems and things like that, the USDA is more simpler when it comes to testing soil and grains than the USCS and the AASHTO systems. And that's just because there's more process, there's more procedures that you would have to go through the USCS and the AASHTO classification systems. So, again, not a lot of comparison, but there is a comparison on the different soil it really depends what soil you're testing, how you want to test it, and what you're looking for. What results are you looking for of the classification systems depends on what system you would want, what system is best going to be for you on your results. If you want to get some soil that just from, if you want to go plant somewhere, this and that, maybe USDA is the way to go because you're planning and trying to grow something. If you're trying to build somewhere, build a building, this and that, probably going to go with the AASHTO, or you can go with the USCS, because those two are mostly for, highway work, and, ASCH is the Highway Administration, so, that's definitely going to be more for, big areas. You're excavating a lot of areas, you're digging a lot of dirt up, you got to, dig back this landslides, this and that. That's all going to go into those, where USDA is more on your soil testing and what can you do to make that soil better. A lot of it goes into fertilizers, a lot of it goes into how to treat your fields, how to maintain your fields, things like that. So here I have the summary. The U.S. Department of Agriculture is a federal agency. I just have a little summary of what I talked about all today. So I'm just going to read over them a little bit. Is a federal agency responsible for overseeing various aspects of agriculture, forestry, development of food. It was established in 1862 with the mission of supporting farmers and ensuring a safe, nutritious, and food supply for Americans. Today, its work touches a wide range of topics, including food safety, agricultural research, economic development, and environmental conservation. In summary, the USDA is a vital agency that impacts food security, agricultural development, and environmental protection and rural community growth in the United States. So like I said a little bit throughout this whole video, definitely USDA is a big part of how the world and how we all survive today. Like it says, the agriculture development, the environmental protection, the growth in the United States, so like I said a little bit before, if you're gonna go and build a house in this area, you would need to know what the soil strength is underneath that. You need to, because if you start building that house and you get a bunch of rain, you can have a landslide, you can have this, and when you start putting all that weight of that house and the foundation and all that, etc., on top of that soil, you're going to put pressure on that soil, and you don't know how that soil is going to react. Same goes with the USDA. The USDA is the same thing, but not building. You're basically, it's just for farming, you're for food, and things like that. So how can you produce the best product for Americans is what the USDA wants. So when you go out and you travel the country, next time you're, down west or, in the Midwest, you get all those acres, you get all that land, you see all that land. Those farmers have a lot of work to do because they want to produce the best food and best product to whoever they're producing for, because that will earn them more money. So that's where the USDA will step in and try to help those farmers produce the best food supply for Americans. So, like I said, if you have a, 25,000 acre flat land, and you want to get a soil, and you want to plant there, and you want to plant stuff there and grow stuff, you want to plant corn, you want to plant whatever, the best thing is to go and get a soil test from the USDA, because they will do a test for you and give you results on how your soil is. Now, depending on if the soil is bad, depending on the area of the soil, depending on your situation, on the results, you might need to do some fertilizer. Fertilizer is basically a strengthening or helping the soil get to where it needs to go to help your product grow better, faster, and a better product. So that's about it for my presentation here on USDA, the United States Department of Agriculture. My name is Evan Carter. I hope you guys all learned a little bit on the USDA federal agency here, and hopefully you guys get a little bit more interested after this video and want to dig into it a little bit more and get connected with it like I do. I want to thank you guys again, and have a good one. Thanks. Bye.